Good morning. The topic of my presentation is delayed flights prediction. These days, flight delays have become very important due to reasons like bad weather, technical snag, or there is an increase in the aviation industry which is leading to air traffic congestion. These reasons are the genuine reasons why flights are being delayed. But this also causes a damage to the reputation of the airlines. Their image is tarnished. At times, the customers they switch airlines so that their work is not delayed. I will just tell about two real life examples over here. Before coming to India on the 5th of April, my joining was on the 5th, so I departed from 3rd, and there was such a hue and cry at the Delhi airport just a week before that. Uh, Delhi International Airport is the largest airport in Asia, but just 1 week before I departed, the Vistara Airlines, which is a very well-known airlines, there were some electricity issues at the airport, so the airlines could not board the luggage of the people in an appropriate way. Therefore, there were around more than 500 people who were stuck at the airport, and their flights were delayed by more than 12 hours. Even the luggage was misplaced. So this was one, there was such a hue and cry at the airport. And the day I was departing from Dublin, one flight to the Gatwick London airport, it got immediately cancelled, and the passengers demanded that some of them should be boarded onto our flight if there's some place. And just they went on discussing about this and forgot to start the boarding of our flight to Heathrow, and therefore there was a delay for more than 40 minutes. Now the passengers like me, and there were many others on the aircraft who had connecting flights from a different city like London. Some had to go to Philippines, some others had to go to XYZ place, and especially where you have a connecting flight and you're visiting the place for the first time, it's a big airport, you don't know how to reach the departure area. It becomes very difficult for the person to manage such things, especially for the ones who are in their mid 50s and 60s or the old people, as the flight was delayed from Dublin itself, so a lot of problem was caused when it landed in London, and the earlier flight did not even take the responsibility of the next flight had it been departed from the London airport. So anyhow, the people who are in their mid 30s 40s, they can easily run and manage and move from one terminal to the other, but many old people face a lot of problems. There were many who even missed their flights because it was not easy to reach from the arrivals to the departures within 15 minutes. So these are the reasons why the customers get annoyed when uh, when such delays take place. So therefore, my research deals with the objective of my research is to predict the flights which have been delayed by more than 15 minutes. There are 8 carriers going from the three busiest airports of Washington to New York, and I have applied the logistic regression model to depict how many flights have been delayed by more than 15 minutes. Now, predictor variables like scheduled hour of departure and day of the week, weather, origin, destination have been used to predict the number of flights which have been delayed by more than 15 minutes. Now, such predictions have to be made because they make it clear for the airlines to know that they are facing a huge economic loss. Any flight which is cancelled or delayed faces a humongous loss, and there are many people who go for business trips, so they also face a lot of loss in case the flight is delayed. Therefore, it becomes very necessary to make such predictions. Moving on, the description of the data set is there were attributes like scheduled hour of departure, day of the week, day, month, departure time, destination, delay. Then there are 8 carriers in the data set that are flying from the 3 busiest airports in Washington to New York. There are no missing values in the data set, and the delay column is the only categorical column in the data set which deals with two kinds of values, on time or delayed. So it becomes very necessary to first look for missing values. There weren't any missing values in the data set, so then I saw if there is a categorical column. Yes, there was. The delay column had to be converted to the numerical column since all the statistical and machine learning models are based on mathematical equations. It causes much problem if they are not converted to mathematical models, and the machine learning or the statistical models can be applied easily once they have been coded to the mathematical learning models. So the delayed values, if a flight has been delayed by more than 15 minutes, this has been encoded to 1, and if the flight was on time, it has been encoded to 0. Then the data set was divided into training and testing data set. Training data set is the larger part of the data set. 80% of the data set was used for the training purpose, and the model is built and trained on this data set. Testing data set, once the model has been built, the performance of the model is judged on the testing data set. The performance on both the models should not vary a lot, and the generalization error is calculated. It is the error rate. It is tested on the data set to see that how the model performs if it comes across any new instances that it has never seen before. Then we come to selecting and training the model. Here regression analysis has been done. Now, according to the statistics of the past flights, we predict the delays, the further delays, and regression analysis is a mathematical measure or establishing a relationship between the explanatory and the predicted variables. Now, here we have to predict if a flight has been delayed by 15 minutes or not. So whether the task is yes or no. Such problems are known as classification problems. So here a predictive modeling technique known as regression analysis has been used. Binary logistic regression has been used because the flight can either be delayed, therefore that is the probability of success, which is taken to be 1, or it can be on time, which is the probability of failure, which is taken to be 0. Then there are many kinds of regression: linear regression, non-linear regression, or polynomial regression. So whenever there is a straight line between the explanatory and predictor variables, then it's a linear regression, and if the straight line is a curve, then it's known as a curvilinear regression or a logistic regression. Moving on, this is the difference between logistic and linear regression. Now, here we see on the left hand side, we can see the linear regression, the line of best fit for linear regression. Here the y, it lies in range. Linear regression is performed when the values are continuous. So here the y values are lying in range. They can even go beyond 1, or when y is 0, they can even go below that. But in case of logistic regression, we calculate the probability of success or failure, and probability can always lies between 0 and 1. So predicted y will always lie in the range of 0 to 1. It can never be more than 1, or it can never be less than 0. And logistic regression is performed when the predictor variables that are used to predict, they are not continuous, they are fixed. So in this case, we have applied the logistic regression model because the task could either be delayed or it could be on time. It is either X or Y. Logistic regression has been applied because all the explanatory variables in the data set like carrier, scheduled hour of departure, origin, destination, all these have fixed values. We don't see any continuous values uh, since we have fixed values uh, in the as the explanatory variables. Therefore, the logistic regression model has been applied to predict if the flight will be on time or it will be delayed. Now, this is the sigmoid function. The sigmoid function is also known as the S-curve. Now, if we see on the y-axis, the values of y will be 0 for certain values of x, and then there is a transition from 0 to 1 in the form of an S-shaped curve, and the values of y will be 1 for certain values of x. So here we have just clipped the best fit line that we saw in the linear regression graph, and this is known as the S-curve or the sigmoid curve. Logistic regression is always applied when the predicted variable is categorical or discrete. So here there is a transition from 0 to 1, and we have to calculate the probability of success or failure. So it is done with the help of a sigmoid function, and the values, the mathematical formula for this is y is equal to log of probability upon 1 minus the predicted probability. Then the data analysis is performed after dividing the data set into the training and the testing data set and applying the logistic regression model, that is the GLN model. After the model has been applied, we see that how many predicted probabilities of success are more than 50% and the ones that are below 50%. So the model predicts the default probabilities are predicted by the logistic regression model if whether the flight has been delayed by 15 minutes or not, and depending on these default probabilities which have been predicted by the logistic regression model, we decide a threshold. So here we decide a threshold whether it has to be 0.5 or 0.3. Then a confusion matrix was created to see that if the error rate is less when the threshold is taken to be as 0.5, or if the error rate is less when the threshold is taken as 0.3. So we calculated the error rate by creating the confusion matrix in both the cases, and we saw that the error rate was 17.46% when the threshold was taken as 0.5, and when the threshold was taken as 0.3, the error rate was 21.469. So the threshold that gives us the less error rate, that is 0.5, it is chosen. Now all the probabilities which will be below 0.5 will be taken as 0, and the probabilities that are above 0.5 are taken as 1. Then the model is tested on the 441 values in the testing data set, and we see that 364 values out of the 441 values in the testing data set turn out to be correct. So this is a high accuracy that was given by the logistic regression model. Now, the conclusion is the logistic regression model was chosen because the predictor variables, as I had already told, all of them were were fixed, they were not continuous. Linear regression models are only chosen when the predictor variables are continuous. Then by making such predictions, we also get to know if we also get to know which are the best days and best times for traveling, especially in case of the busiest airports like Washington and New York, which are among the top 5 most busiest airports in the world. And there are many people who travel for frequent business trips. Then there might be an emergency at someone's place at home, so people might have to travel from one place to another. So in such cases, flight delays affect the people in a lot of ways. And maybe a customer is satisfied with the flight and every now and then chooses the same airline to travel from one place to another. But if the flight starts with frequent delays, then the customers might have to switch airlines, and this is how certain airlines can even lose their customers, which causes them a big loss. Then a lot of areas of improvement can also be suggested and areas of concern to minimize such delays. But here the logistic regression model, it accurately predicted 364 correct cases of the flight being delayed by more than 15% out of the 441 cases in the data set. So thank you.